Hey guys, so today I'm going to walk you through how to determine the strength of your hand in Texas Hold'em. To do this, I'm going to use Python in a Jupyter notebook in Visual Studio Code, which is what I have opened here. So first I'm just going to take you through a couple of the packages that I'm using in order to accomplish this. So Pandas is going to be used to store the data. It's a data frame library in Python. Um, Jupyter, Notebook, IPyKernel are all needed to run Jupyter notebooks in Visual Studio Code or another environment. Um, Matplotlib and Seaborn here are going to be used to create a visualization just to get a sense of the overall distribution of the data. And Texas Hold'em Utils is an application or a package that I developed myself. It's available on the Python package index, and I'll include a link to that in the description. All right, so the general question that we're trying to answer is how do the possible starting hands, so in Texas Hold'em, we dealt two cards. We want to get a sense of how good any given two cards that you might be dealt are compared to what your opponents might have been dealt. So we're going to start with one example here of the Ace of Hearts and Six of Hearts. So using that Texas Hold'em Utils library, we'll create a card object for each of those, create a deck object with all 52 cards in a standard deck of cards, remove those two cards, the Ace of Hearts and the Six of Hearts, since that's our hand, and no one else can be dealt those cards in the game. And then one option would be to try and brute force this, where we're looking at calculating all of the wins, losses, and ties against all the possible hands that the opposing player, we'll stick with just one player for now, might be dealt. So as you can see here, this is a fairly intensive process with lots of nested for loops, where we start out with 50 possible cards for the opponent's first card, 49 remaining cards for their second card, and then go through the flop cards, the turn, and the river. So I let this run for a little while just to give you a sense that it does take quite a while, but ended up interrupting it after a few minutes. And to give you a sense of why that is, so for just calculating the odds for that one scenario where we're dealt the Ace of Hearts and Six of Hearts, there's 50 times 49 times 48 times 47 times 46 times 45 times 44 possible combinations to explore. You can optimize that away a little bit, but that leaves you with half a trillion combinations of different scenarios to run. So even if you were to, in a really fast computing environment, process a million of those per second, it would take about 6 days to compute. So we're not going to accomplish much with that approach. So the more effective approach would be to take a random sample of a few thousand different hands to get a sense of the win rate for that particular scenario. So this is, several orders of magnitude more efficient than doing it for everything, kind of brute forcing the solution. Taking a random sample, we're able to get a better sense of, or get a decent sense of what the win rate might be with a far less complex time space. So here we have 100 or 10,000 possible, or 10,000 samples that we're going to be generating. We've got a deck that we're going to be creating for each round and copying the cards that are available from our original deck, shuffling those, producing just a random order of those cards, and then assigning an opponent pair of opponent cards, 3 flop cards, a turn card, and a river card, and then using this hand of 5 object, again from that Texas Hold'em package, assigning or assigning my hand as a hand of 5 with my 2 cards and then the 5 community cards, my opponent's hand as another hand of 5 with their 2 cards and the community cards. And this object is going to identify the best 5 cards to use out of those 7 and give a ranking to each. So you can do comparisons where if my hand is greater than opponent's hand, that means my hand would win against the opponent's hand. If my hand is less than the opponent's hand, my hand would lose. And if they're equal, it would mean that there's a tie. So running that, we get 5,800 or close to 5,900 wins, about 3,800 losses, and 317 ties. So using those numbers, we can produce a win rate as a percent, where we're taking the win count times 2 plus the count of the number of ties, and dividing that by double the total of the wins, losses, and ties. So essentially, a tie here is counting as half of a win, and a loss counts as 0 here. And that gives us a win rate of about 60%. And we can run this a few different times and get slightly different results, just to show that we are producing a sample, and that sample is staying pretty close to the win rate that we'd expect each time. So now that we have a sense of how well that Ace of Hearts and Six of Hearts do against a random opponent, let's figure out the rankings of all the possible combinations. So here we're going to take a similar approach where we're producing a random sample for each of the 52 first cards in the deck and 51 second cards in the deck. So again, that it does grow a little bit in complexity, and for that reason, we're only going to do 1,000 samples for each instead of the 10,000 that we did previously. And then just use the same process here where we're counting wins, losses, and ties. And at the end here, we've got a data frame defined at the top with 3 columns, the first card, the second card, and the win rate. And down here, we're adding at the end of each iteration the win rate for each first, second card, and then that win rate as a percent. So that gives us a win rate for each combination of 2 cards in the deck. And next we have a histogram that kind of shows the distribution of win rates for each of those. So you can see it's centered roughly around 50% as the win rate, with a long tail here where some scenarios, probably ace-ace, are in this upper range, maybe ace-king suited, have a over 85% chance of winning against any random hand in the deck. Now we can take a look at that data. So I have this Jupyter plugin installed where I can open up the data as a table and see the rankings of hands. So you can see that Ace of Spades and Ace of Clubs, like I mentioned, Ace-Ace is pretty high. It's considered a pretty good hand in Texas Hold'em. And then we've got things like pair of kings, let's see, maybe a pair of queens, a pair of jacks, and so on down the list. And at the very bottom, it's quite a long list here. We have things like 2 of hearts, 4 of spades, so 2-4 offsuited is a pretty poor hand. You'd expect maybe to see 2-7 here, but maybe because that's generally considered the worst hand in poker, but maybe that 7 is enough to give it a slight edge, or it could just be, since we're taking a random sample, there's going to be some error where, maybe these are all right around 30% win rates, and if you were to take a larger sample, that 2-7 would kind of filter down to the bottom, or if you were to run another sample even of with the same number, so 1,000 for each. But anyway, that gives you a sense of the overall rankings of different hands. And If you want to do this and not go through all the effort of copying all that code there, you can use a function in this Texas Hold'em utils library called get handbrake details, where if you run this, you'll get the expected win rate for the number of players that you specified, or you cannot specify, and it will assume 2. It'll give you the percentile, so how many hands are worse than that. It looks like it's better than 82% of other hands, so it would probably put it at around maybe a 60% win rate. As we're looking at the distribution up here, 80% of the total area under this distribution is going to be to the left of that 60% where we calculated that win rate, and 20% with this kind of long tail is to the right of it. And you can also do the same for different numbers of players. So if you had a game where you had 3 or 6 or 9 players, you could enter in that player count here and get the win rate for that particular scenario. So this ace-6 of hearts seems to do pretty well against the field with a 3-player game, where the average is probably 33% win rate, and this one has 42.6% win rate. So I'll include a link to the code in the description in case you want to copy it and try out different scenarios. I'll also include a link to that Texas Hold'em utils library in a Python package index in case you want to clone that down or copy that down and do some more in-depth analysis of any hands that you're interested in. So thanks for checking out the video, and we'll see you next time.